Okay, so here's my problem. I've got two charges, right? And you can see here, there's one that's minus 6.73 microcoulombs, and it's separated from this other one that's minus 4.61 microcoulombs. This one is at the origin of an axis, and this one is located 2.0077 meters up on the y-axis. And the question is, I want to know where is the electric field zero along the y-axis. Okay, so first off, I know that that point where it's zero has to be somewhere in between these two charges, right? Because these are both negative charges, so there's going to be a point somewhere in here where those two sets of field lines are going to cancel each other out. So this one, the field lines are pointing this way, and this top one, the field lines are pointing up, and so at some point those two are going to cancel out. So I'm just going to draw it somewhere in here, right? Call that my point. Okay, so I want to know what this distance along the y-axis is. So I'm going to call that y. And so let's do a couple other things, right? So I don't want to just use numbers. I'm going to solve it algebraically first. So I'll call this Q1, and I'll call this charge Q2. And I'm going to call this distance here between the two charges, call it D. Okay? And I want to know this distance for point P. So let's go through and solve this. So we know where the electric field is zero, where E is zero, that means E1 equals E2. The electric field from charge 1 will cancel in magnitude the electric field from charge 2. So E1 for E for charge 1 will equal E for charge 2. Okay, so let's go write these out as our equation, right? So we're going to use the equation for the point charge, the electric field from a point charge. So I have K times Q1 over R squared, where this is Q1 and this would be R, equals K times Q2 over R squared, where Q2 is this one and R for that one is this distance here. Okay, so let's make some other substitutions, right? First off, these both have K in it, right? So I can cancel out the K, and I'm left with Q1 over R squared equals Q2 over R squared. So let's substitute in what these R's are. So Q1 is over this distance here, which I said was Y. So I'll call that over Y squared. And then Q2 is over this distance here, right? So that distance there I can find from the difference between the distance between the two charges and this distance. If I subtract those two, I'll be left with that distance. So I'll call this D minus Y. So D minus Y squared, right? So Q over R squared, Q over R squared, set those equal. Okay, so now, once you've done this, like you've solved it, right? But now you just have to do algebra to get to the point where I can solve for Y, right? So let's do some manipulation to end up with Y. So I'm going to cross multiply first. So Q1 times D minus Y quantity squared equals Q2 times Y squared. Okay, so now let's take the square root of both sides. So that gives me root Q1 times D minus Y equals root Q2 times Y. So now let's move this Q1 over. So I've got D minus Y equals root Q2 over root Q1 times Y. So from here, right, I want to get Y by itself. So let's, I can get rid of these parentheses, right? So now I have D minus Y equals this. Okay, so let's come over here. So I'm going to add the Y over. So I get D equals Q2 over Q1 root times Y plus Y, because I added this Y over. That equals D. Okay, so now let's pull Y out, right? So I can say that Y times root Q2 over Q1 plus 1, that's the same thing as this, right? Equals D, right? So I just pulled the Y out, so this Y will distribute in to give you that. Okay, so let's solve for Y. I'm there, home free. So that's equal to D divided by this whole mess. So that's root Q2 over Q1 plus 1 So there's my answer. So now I go substitute in, right? So I'll say, I've got it. I can just plug in all my numbers. So y will be equal to d, which is 2.0077 over the square root of q2 over q1. So that's 6.73 over 4.61. I'm not using the negative signs, right? Because it's only, and that's an absolute value when you're using Coulomb's law, right? And I don't need the microcoulombs because if you remember your exponent rules, when you divide those two exponents, they're going to cancel out. So I'll just leave it like this instead of drawing an extra exponent. Plus 1. And so when you do this, I end up with 0.909 meters. And that's your answer, right? So we had to set them equal. That was the easy part, setting them equal to solve at that point. And then the hard part was doing the algebra to figure out how to isolate y.